Hello, in this recording I would like to talk about a rather more advanced technique in Gradle. This is about how you could test two different implementations of the same thing using the same tests. As a little demo, I would like to show how I applied this technique for one of the modules we have in Kotlin. We have this module called the Objective-C export header generator. And basically what this does is it takes Kotlin code, whether or not it's source code or binary, and it will be able to generate the corresponding Objective-C header. This tool previously was just implemented with the old compiler K1, and for the IDE we wanted to have a specifically newly written implementation that is based upon K2. We therefore used some wrapper around K2 or high-level API called the analysis APIs, but we still needed to completely re-implement the entire component. For us to make sure that we are re-implementing it correctly, aka matching entirely what the previous implementation did, we had the ability to write certain tests that in the end ran for both implementations. So I would like to showcase this and then from scratch create a new project and show how you could imply a similar strategy to test your implementations. Just to give a short overview of this component, we have here the two implementations. We have the one that was the previous one, K1. We extracted this to a separate module. And we have here the new implementation that is based upon the analysis API. So we have those two rather distinct implementations of this Objective-C export, both basically getting Kotlin source code in and returning some Objective-C headers out. Now, here's how we wrote the tests for this. We have, for example, something like this Objective-C header generator test. And you will see that basically what this does is it will go to this test data. Let's look into headers. And let's open just a simple test file. And you can see that we have here some Kotlin code. And the assertion of the test will be that it generates exactly this header. Now, how can we run such tests against our two implementations when they are living in very separate modules and they do not share some common interfaces? Here is this test. Let's just try how we could theoretically run this test. We can see we are allowed to just hit run from within the IDE. And as far as I'm concerned, since I previously executed this test, we will now be able to see in the run configuration that now we executed this test with the analysis API and with K1. And you will see that all of those tests, let's say here, are now prefixed with K1, test companion, and we should be able to see the same test being executed with the analysis API. So here's the second test, analysis API. So if we would theoretically just want to execute one of those tests and we want to execute it just for the analysis API, then we are allowed to run this particular test just for the analysis API. Now, maybe you have been able to see this, but the magic behind all of this is that we are allowed to inject this header generator abstraction inside this test. And I would like now to switch to the empty project and see how you could set up something similar like this. Here's the project I would like to showcase how this can be done. In this project, we have a current implementation of some kind of robot. This robot will perform an action based upon a string. Let's imagine it's a robot that can control your home. So you can prompt it to turn on the lights. It will return that the lights are turned on. You might ask it to turn off the lights, and the lights might get turned off, so on and so forth, until it reaches no more prompt that it can handle. So it just returns unknown request, and it reflects what you prompted. Now, maybe let's imagine that this robot implementation is not ideal anymore. You wanted to re-implement it, but you still want to make sure that your new implementation is behaving exactly like the previous one. So let's look into our new robot implementation. We thought that maybe it makes sense for us to also refactor the API a little bit. So in this implementation, we will get in our request, we will return a response. It's a little bit more typed. Looks good, maybe a little bit improved. You get the point. It's just an imaginary project to showcase how we could write tests for this. So let's set up the root Gradle project to be able to run such JUnit tests. Let's get started. For the first thing that we want to do is we want to create the two test tasks, that one that is able to invoke the tests with the current implementation and the other test task, which is able to invoke the same tests with the new implementation. Okay, I think I said both times new implementation. I don't know. Let's see. So let's create or register and the first test task, which will allow us to run with the current implementation. So we are registering a test task, test current implementation. And let's register another task, another test task, and call it test new implementation. For both of those test tasks, we would like to use JUnit 5. So let's use, let's say JUnit use JUnit platform. And let's add the necessary dependencies. So first of all, I really like the Kotlin test assertions or functions more. So let's add Kotlin test JUnit. And now let's add the corresponding JUnit dependencies. So let me copy paste that from someplace. Yeah, so let's, for this, we added now JUnit 5.10.2, and we want to use the test assertions and the annotations coming from Kotlin test because I think it's just rather nice and clean. Let's start by writing the actual tests that we would like to share across both implementation modules. So for this, let's create a new source file for this robot in SSC test Kotlin. Note, this is still the root project, so we have those two modules, current and new. They contain the individual implementations. Inside the root project or the parent project, I'm now creating a test for both of those implementations that we can run for both of those implementations. So let me call this robot test. And inside this robot test, we can, oh, I said I want to use the Kotlin test annotation. Inside this robot test, we can just write some simple tests for how the robot will, or for what the robot will return us if it gets the prompt to open or close the door, as an example. So let's create the first test open door, and create another test for us to check if the close door functionality works. Since we do not have any access to any kind of robot, we have no idea how we could even write such tests because we cannot just create the robot or the new robot as we have here. Let me repeatedly show. This is the new implementation living in new. This is the current implementation living in this current module. And since this root project does not have a dependency on either of them, and maybe they are even completely incompatible at runtime, so you should not even have, you should not compile against any of them, you do not have access right now. So for a simple solution, we can now create a small interface, call it robot implementation, and we create some interface that both implementations can then again implement, or we can provide wrappers around them in order to make them testable. So we can create a function handle where we are allowed to press in a prompt, and we just let it return a string again. For this robot test, we can simply assume that this robot implementation will just magically be available to us This being available makes it now simple or easy for us to write the test where we just send the robot some request like open the door, and we assert that the response will be door open. Okay, similar to the request of opening the door, we can say that once we ask the robot to close the door, it responds with door being closed. We should now be able to run the test. Let's first lead some run configurations that were available previously. We can now see that running the test allows us to select multiple run configurations. We can select the two implementations and execute them both. So we already have some kind of IDE support to invoke both of our test tasks, which is great. No wonder that they fail, because we have not done anything to implement this robot impulse. So there's just this empty interface. There's a constructor that requires this being passed. And of course, nobody ever wrote any kind of code to support this. So it fails with no parameter resolver registered for parameter, blah, blah, blah. Let's see how we can make this no parameter resolver happy and how we can provide this robot test with its robot implementation. For this to be done, I think the easiest is that we go to the implementations and create inside current and new some kind of adapters that they are allowed to, for tests, implement this robot impl. So we need to have access to this robot impl for the current and new module. Let's therefore extract this robot impl into some compilation that can be accessed as a dependency on current and new. In the previous sessions that I recorded, I have been talking about Kotlin compilations, and I've been talking about configurations, how to share the output of some project with other projects. Now let's apply this knowledge and see if we can create a new compilation that is able to host this robot interface that then can later be accessed by current and new. In order for us to do this, we open the Kotlin block and we create on the current target. Note that this is a JVM Kotlin project. There is only one target. So there is no targets.get by name. We already know that the target will be a JVM target. So we can just access this single target by calling target dot. Now here, the compilations allows us to create one new. We call it test interfaces. Test interfaces compilation. And inside this test interfaces compilation, we can now place this interface of robot implementation. Here is how we can do this. We create a new source folder. Here's test interfaces. The IDE automatically gives us auto suggestion, test interfaces. And from this robot test, we can extract this robot implementation and put it here inside a new source file. So let's call it robot impl. Paste the code here. Here's this robot impl. Maybe it's also nicer to not call the interface impl. That's kind of confusing in my opinion. So let's call this robot under test. Okay, this is also a stupid name, but bear with me. The naming is hard. Let's call it robot under test. Rename file to robot under test. Yeah, I want to do this. Yeah. Let's see if we can already access this. And of course, just because we have created a new compilation does not yet mean that our main compilation is able to access this. So let's tell the main compilation that it is allowed to access the test interfaces. Let's therefore request the main compilation like this, and associate with And now associate this with the test interfaces compilation. You see that us calling associate with will now allow us to use the output of this compilation. Basically, it's a kind of dependency. In Kotlin, I would say there are simple, like 3 dependency kinds that we can use. First is the regular dependency. You see, a regular dependency is if I am creating a source module and I depend on anything that is published to Maven Central or any other module in my project. This means I can use all the public API. We then have the associated dependencies. We also call them friend dependencies. You can now use even internal interfaces and internal APIs from these associated dependencies. The naming is not ideal here, I get that, but it is also a very advanced API, so use it with a lot of caution. This associate with is also the mechanism on how the main compilation can see the internal, vice versa, how the test compilation can see the internals from the main compilation. So the test compilation has an associate with kind of dependency to main. Cool. We now have this test interfaces compilation being available for us in this robot test class, and we have this robot under test interface that is available to us. Let's again run the test and see if there's anything new that we can see. Nope, but again, that is not too surprising since we have still not implemented any robot under test. To me, it's still interesting to look into what we have compiled, and we see now that we have compiled something for the tests. We have this robot test class, and we have also compiled this robot under test. Now, how can we share this robot under test with current and new so they are also free to provide some implementations for this? This can be done by us exposing this test interface compilation. We can do this by creating first a jar that we then are free to ship to other projects. Therefore, we can directly inside this Kotlin block create a new task, a new jar task. Let's call it test interfaces jar. And we want to use the test interfaces compilation, output, classes, tiers, which all get put inside this jar. Let's have it like this. Well, test interfaces jar equals. Now, how can this jar be exposed to other projects? This can be done by configurations. We have tackled this topic in one of the other recordings, but as a short summary, a configuration is something that can be either requesting some incoming dependencies. It's a dependency container, if you will, if you want to call it this way. But it is also a mechanism for you to share some artifacts with other projects, either by you publishing to a Maven repository or you allowing other projects inside your build to depend on this. Therefore, we can create a configuration. Let's call it test interfaces configuration by configurations.creating. Let's immediately call it consumable. Test interfaces. We call the configuration test interfaces. And we would like to add this test interfaces jar as an artifact. So in order for us to do this, we can just provide the artifact to the outgoing publications of this test interfaces configuration. So far, so good. Let's sync to see if we have done something horribly wrong. We're here now in the current module. So this is the build Gradle KDS of the current module. And now in my head, it would make a lot of sense for us to create another compilation inside this current. So the robot that we would like to make available for tests is now here under the main src main/Kotlin robot. And we now need to provide this robot under test implementation from it. So this adapter interface needs to be implemented. It doesn't make a lot of sense to do this inside the main source set, right? Because in this case, we would kind of ship code that is meant for tests inside main, and probably you would not feel that this is right. Maybe it would be totally okay, but you get the point. It is somewhat not ideal. You might ship too many classes. It is not what we want to desire. So what we can do is create a new compilation. Inside this compilation, we will be allowed to implement this robot under test. And from there, we can wire this back to our root or parents tests to see if this adheres to our tests. Let's do this. We therefore again go to Kotlin block. We ask the target to create a new compilation for us. So let's call it the test test utils, or how would we be able to call it? Let's call it test let's call it test adapter. I don't know. Naming is hard. Let's sync. So the IDE should now be able to provide us with this test adapter Kotlin. Naming is hard. I don't like this test adapter name, but you get it. Let's just pretend this is a good name. Inside this test adapter, we should be allowed to use this robot. So what we need to do is do the same trick that we did in the root project, where we associate this test adapter with main. So for the main compilation, we first need to get this by name. We get the main compilation here. We have this test adapter compilation there. And now we tell the test adapter compilation to associate with main, or with the main compilation. And by doing so, we should now be able to use the robot implementation inside any kind of code that we write on the test adapter. So we might now call this the current robot under test input, because the interface will be called current robot under test. And the interface we want to implement is this here, robot under test, which will then be used by this robot test. And here's this for the current implementation. So this is the robot under test implementation for the current module. We will not be able to simply use robot under test, so we should now make sure that we can get this test interface, this robot under test, being visible also inside our test adapter here. This can be done by using the source sets. We can, the best, or one idea that might make it simple is by just using this default source set. Inside there, we get access to the dependencies block. So we are now using the default source set of the test setup, the compilation, and now we can use the implementation configuration to ask for the root project. The root project is this. And we can now say that we are specifically interested in this test interfaces jar. In larger projects, you should probably not rely on like matching the strings here. We have shown previously how Gradle has this concept of attributes on configurations, so it can match on what you actually want. For this, for the sake of this video, for the sake of this recording, I am going to just tell it that we are interested in this test interfaces jar. Let's sync the IDE and now see if we are now able to see this robot under test. We did not. Test interfaces. Let's see if we did it correctly. So here's this test interfaces. The configuration was called test interfaces, and this is a good example on why you should not rely on the strings, but you should rely on semantic attributes. Let's sync once more. Yeah, we see that we are now free to implement robot under test. We now need to implement this handle method. For this, we can create this robot and ask it to do the action. And since it also returns the string, we can just delegate this .handle to this perform action of our original implementation. It might be a little bit nicer for us to use dependency injection here, as in like I am requesting things in the constructor in despite or in favor of just creating it on the fly from this class. So this class, this only responsibility is it will get a robot robot instance from this current implementation, and it adheres to this robot under test interface. This is already great. We now need to do the wiring of this current on the robot test implementation back to the test. So this here should be somewhat available when we want to execute this test. This can be done by using one of the mechanisms of JUnit, which is called a parameter resolver. And this parameter resolver can also be directly implemented inside this test adapter here in order for us to tell JUnit that if somebody would request at runtime that robot under test is requested, we know how to provide this request, we know how we can create this instance, and then we will provide this instance. In order to use JUnit, here in this compilation of the test adapter, we also need to copy this dependencies. So let's add the dependencies of to JUnit 5 here in our test adapter as well. We can sync. And now we can implement a parameter resolver. So we call this robot under test, robot under test parameter resolver. And this implements parameter resolver from JUnit. This requires us to implement those two methods. So it's probably nicer for us to let it now implement with the right naming. This parameter context and extension context, we are free to assume that they are never null. This is a Java API, so it's not properly this is not properly, sorry for that, it's not properly annotated. That is not a huge problem. We support only parameters that are of the type robot under test. And if we want to resolve this parameter, we can just create a current return current robot under test implementation. And for that, we can implement this test. How can we now wire this up to be automatically detected by JUnit? This can be done by us providing resources. Resources are used by JUnit to load this parameter resolver or any kind of extension. Under the hood, it uses just a service loader from Java, so it should be simple for us to provide the resources here. We can therefore use the default meta inf/services, and inside there we can create this org, the JUnit dot Jupyter dot API dot extension dot extension. Simple, isn't it? So inside here we can provide this current robot under test. Or we can robot under test parameter resolver. That is the extension we actually want to register. So let's see. Yes. Now you also are able to see that the IDE figured out that this robot under test parameter resolver is now somewhere used. It's used by us registering this as an extension from metainf or inside metainf services. Okay, we have now this test adapter. We need to wire this back into our tests so that if JUnit runs our tests here with the current implementation, robot under test will require our parameter resolver to run, providing us the current implementation from this module. This means that we once again need to wire back the compilation of these classes into the runtime of running these tests for this test task that should test the current implementation. And this can be done in a similar way. We now need to create once more a jar task. So we call this file test adapter jar. Autocomplete helped us here a lot. From the classes directory of our test adapter compilation, we now might want to create a outgoing configuration once more. So we can request this jar file from another project. So let's call this test adapter configuration. It's again consumable. We in the artifacts provided the test adapter jar. Let's sync and go back to our tests. Here is the build.gradle.kts of our parent, which contains this robot test. And for us to have available this current robot under test input at runtime, we need to somewhat declare a dependency to it. Now, dependencies can always be declared by using configurations. So let's create a new configuration called current implementation by configurations creating. We then can use the dependencies block to attach a dependency to this current implementation. So for current implementation, we can say that we want to have the current project, but we also want to use current implementation project current, but request the test adapter. So we need to copy paste the string again. It would make a lot of sense to use Gradle attributes instead of me hard coding here the strings. What we have done here now is we created a configuration that has two dependencies. One, like the main classes of the current, and then we wanted to additionally request a test adapter. We can wire this up by adding this to the class path. The class path, therefore, should be the class path plus the current implementation. And we should tell JUnit to automatically scan for extensions. One easy way to do this is by adding the system property here. Now, we should now have everything wired up. We can make this a little bit nicer by using the plus assign operator. Now that we have wired everything up, we added the current implementation as a dependency to our test. We also added the test adapter to our test. So those dependencies will be available at runtime. We told JUnit that we want it to look into the metainf services automatically to discover these extensions. We should now be able to execute this test. Let's again delete the previous run configuration. Yes. We should now be able to execute this test by selecting a test current implementation. And we still see no parameter registered for parameter. This is an interesting case. Let's investigate what's going on. Looking into the current build, we see that there are several classes compiled. We see that the robot will be compiled, but also our current robot under test implementation and the robot under test parameter resolver are compiled. We also see that there is a metainf generated. Let's look into the current jars. We see that the current jar does only contain current robot under test input, robot under test parameter resolver. So what we are missing here is like seems that this current jar doesn't package the robot, and it also doesn't package our resources, which are here on the test adapter resources. So of course, if we do not package this resource file, and if we do not package the robot correctly, then we will not be able to run this test. We can see what's going on here in our current code. Let's reiterate what we've done. We wanted to create a jar file for our test adapter jar. From there, we packaged all the classes directories, and immediately we can kind of assume that there might be a problem. If we just package the classes directory, we will not be able to see any of the resources. That makes kind of sense to me. We can try to switch this out to all outputs, including resources. And maybe we see that this current jar is also used for the main output, so we should disambiguate this. We can do this by using our archive classifier, and we use test adapter for that. Let's rerun the test. First, before we even look at what now the new test failure is, let's see if the output that is now generated makes more sense, just to check. We see a current.jar. This current jar still contains current robot under test impl. I guess this is just an artifact. Let's clean this. Let's rerun and see if this is still there. Going into the build directory, we look into libs, we will see the current jar and the current test adapter jar. Now this will include the current, this will include the services here, also including the class file here. I'm unsure why this current jar here also is going to include current robot under test info and robot under test parameter resolver. Let's look into the test failures. Oh, it looks like the robot test here actually was invoked correctly. We expected it to be using closed with an lowercase, but the actual implementation returned opened and closed with an uppercasing. So let's rerun the test. Yay, we see now we are able to run this robot test, and we are able to execute this for the current implementation. How can this now be executed for all of the implementations we have? We can delete this robot test here once again. We can run, we can select multiple of these implementations, hit enter, and we see the implementations that run for the current implementation. They are green. The new implementations ones are red because we did not implement anything for them. Also note that I have not added anything to make it easy for us to distinguish what test is currently running, whether or not it's the old implementation or the new implementation. I will cover this in an upcoming video. Now let's try to wire everything up for the new implementation as well. This probably can be done quite quickly. So we can copy paste most of the code that we have here from the current. It makes a lot of sense, of course, to use something like build src to share this code, but this is just a demo video on like how this works overall. This is not a best practice video. This is like educational video on the strategy of running such tests. I am therefore just copy pasting all of this code. We then wire up everything here in a similar fashion by copy pasting this code as well. We now have the new implementation. Maybe it makes sense to add this and copy paste it to this part. So we have the current implementations code here and code that handles the new implementation there. Let's copy paste the code here. We, instead of the current implementation, we want the new project. We want new and the test adapter from new. Let's rerun the test. Makes sense. There's still no parameter resolver registered. We can now create the actual test adapter. We sync the project. And let's be lazy once more and copy paste the test adapter from the previous one. Of course, this will not compile because we have no robot, but we have new robot. instead of the new, instead of just calling the old implementation, we now request a new implementation in this robot under test. We change this to be the new robot under test implementation. Yes, yes. We perform the request. We therefore need to make sure that we wrap this prompt into something the new robot can understand. And then we need to handle this returning a string. Can do this by return return when, and then since this is a sealed class, we can handle the cases, add remaining branches. We return door closed, door opened, lights off, lights on, and we return unknown request. Unknown request. Fair enough. In order to resolve this, we cannot just use the robot. We need to create a new robot. And we probably want to check if our resources here still point to the correct thing. So there's now, again, a robot under test parameter resolver. Instead of creating like the same parameter resolver as we had previously, it will create this new robot under test impl. This new robot under test impl will wrap the new robot to implement this robot under test interface. Let's see if we can now run the tests. Still, we have no success. This failure here comes from a mistake we've done previously. We copy-pasted this block. We copy-pasted this block from the current implementation here, and we forgot to add the dependencies to the correct place. So, of course, we want the new implementation to have a dependency on the project new, and the new implementation configuration to also include the test adapter. Here now we expect, if I rerun the tests, that both of them pass. Now this is one of the ways where you can create this test and execute the same test for different implementations, whilst keeping their class paths separated. Hope this helped. Bye bye.